Okay, kids, let's do it. So what we've done here, what I've done, is we now have our two equations. Put a box around our first equation we created, a box around our second equation we've created, and look what I've done. I have boxed out I2 and I3. Why did I do that? Okay, right here, here's why. Next blurb. Solve your two equations for the non-common I value. What do you mean non-common? Well, look at this. This is an I1 and an I3. This is an I1 and an I2. They both have an I1. That's the common term. That's the common value. So what I'm going to do is solve this equation and this equation for the non-common term. So not I1. I'm going to solve this one for I3, and I'm going to solve this equation for I2. And that's what that means. Solve your two equations for the non-common I value. Let's do it. Let's get these set up so we're solving for I3 here and for I2 in this equation. Just do it. Trust me. It's going to work out. I know you don't trust me, but you should. It will work. This will work. So whatever equations you choose to set up, you're going to have a common value, and you're going to have two non-common values. You solve for the non-common values. Let's solve this one for I3. I'll do this down here, and then I'll erase it. Get it out of the way. I'm going to need this room. I've run out of room. So this is I. So positive 41 I3. So I'm going to take the 41 and divide it into those. I'm just doing this in my head. Do the algebra. Get this to this side, positive 41 I3, and then divide by 41. So negative 30 I1 plus 45 divided by 41 equals I3. So let's do it out. You actually have to get values for this. So 30 divided by 41, 30 divided by 41 is 0.73. Negative 0.73. So this is negative 0.73. Negative 0.73. I1, and then I have to take 41 and divide it by 45. It'd be a little bit more than 1. 45 divided by 41. I said the other way around. Oh, I'm tired. I'm hungry. The Super Bowl's almost on, for crying out loud. I'm not going to get home in time for the Super Bowl. You kids appreciate this. I'm hungry. I'm tired. It's snowing out. Doggone it. 1.1. So this comes out to be 1.1. So put that in. 1.1. We now have our equation set up for the I3, the non-common term in this equation. So I'm going to write this up here to get it out of the way. So I3 equals negative 0.73 I1 plus 1.1. Okay. That equation is now set up, solved for the non-common term. The non-common term in here between the two equations is my I2. I'll solve for I2. So I2 is going to be equal to, let's see, let's move 80 to the side and negative 30 I1 to the side and divide by 21. So that'll be 30 I1 plus 80 divided by 21. 21 means 21, even in college. Remember, even at a frat party. Someday you're going to hear my voice when you're being tempted. You're not 21. You're going to say, Mr. Gramsci, 21 means 21. I can't do that. Thank you. Oh, actually, you're welcome. All right, so let's do this out. 30 divided by 21. 30 divided by 21. 1.43. So that's 1.43 I1. 1.43 I1. I1, yay! And 80 divided by 21. Now a little less than 4, right? Yeah, 3.81. 3.81. All right. So I'm gonna write this equation. I solve for I2. I'll write it here. So I'll get it out of the way. And we're gonna need the room in a minute. So 0.38 I1. Okay. So we got that done. Oh, I'm getting excited and hungry. Doggone it. Did I already say that? I think I did. I'm hungry. I'm gonna go home. I gotta clean the driveway up too. I'm gonna miss Tommy. I'm gonna miss Tommy. All right, so now what we got is two equations. Solve for the non-common term. Now what? Solve for the common I. What? All right, here's what we got going on. I have I1, and up in here I have an I1. So we're gonna solve this equation. Remember I originally set up this equation? In many ways I could have set this up. This will work. I know you don't believe me, but it will. I'm going to solve this equation, my original overall what's going on in here equation, for the common term. The common term in my two equations that we had created, well, I had created, the common term is I1. I need to solve this equation for I1. I1 is equal to I3 minus I2. So I'm solving this overall equation for the common term I1 in my two equations that I had set up. Okay, so I1 is equal to I3 minus I2. We have the values for I3 and we have the value for I2. Let's put those together and do some sweet algebra. Okay, I1 is equal to I3, here it is, negative 0.73 I1, ooh, common terms, gonna be some sweet algebra, plus 1.1, minus, here's I2, 1.43 I1 plus 3.81. And what I have to be careful of is this negative applies to both of these here, so I can't forget. I'm not just subtracting this value, I'm also subtracting that value as well. So I gotta be careful of that. That's a little tricky algebra thing that half of you will probably get messed up on. If I didn't point it out, you're welcome again. All right, let's solve. Like terms. Negative 0.73 I1 minus 1.43 I1. Oh man, my brain hurts. That's a 2. Okay, I got this. I got it. I1 equals, if I add these two like terms, I get negative 2.16 I1. Okay, that minus that gives me that. All right, what else? All right, 1.1, remember, that minus applies to this. So minus 3.81. 1.1 minus 3.81, that one I can do easily. Negative 2.71, right? Yeah, you should check my math on this. Trust me, you should check it. But I think that's right. Okay, now what? Okay, like terms. Here's a 1 in front of this, so this is 1 I1 and negative 2.16 I1. Get these two together, get your like terms together. So add, and we get 3 point, right? This is 3 point, 3 point, I'm running out of energy. 3.16 I1 equals negative 2.71. Whew. All right, we're almost done. Hope you can see that down there. I'm running out of room here. You can see that, right? You can see it. Go over here. Solve for I1. Negative 2.71 divided by 3.16, and that'll give me I1. All right, we can do this. We can do it. 2.71 divided by 3.16, 0.858. I'll make it 0.86. So this comes out to be I1, comes out to be 0.86. Boom! And remember, it's current, so it's I, so it's amps. That's what we just solved for. We just solved for, and the negative. Ooh, that's important. Muy importante. Grande. The negative, don't forget that, the negative. Okay, negative 0.186 is my answer for I1. Here's I1. The current going through this line that I selected as being called I1 ends up being 0.86. What about the negative? You can't have a negative current. That's crazy talk. Right, well, you know what that means? That means I originally set up I1 going this way in the wrong direction. That's okay, it doesn't matter. The math will tell you that you've got it the wrong direction, that's all. The value for it, 0.86, is correct. It just means that the current is really going around this line in the opposite direction that I originally just arbitrarily selected, that's all. So we have the answer for this line right here. We got that done. Woo! Diane. Oh my God, all that math just to get one line. We have to do all that math for 2 more lines. No, we don't. We've got most of it all done, like 90% done. Well, how's that? Well, because remember, here's what we got. This is the common term. I1 is the common term. So I can go ahead and take that I1 and put it here in this value, this thing here, and I can solve for I3. And once I get I3, or I can take this value here and I can solve for I2. I could do that as well. And then once I have I have I1 and one of the others, I can actually go up here and use this simple equation. So the algebra becomes easier at this point. Let's get rid of this. clean this up. Okay, so I know what I1 is. All right, okay, so we've got that done. Let's go ahead and put it in let's solve for I3. Well, let's see, I got I1, I2. Let's solve for I2. I'll solve for I2, because then we can just add those and get I3. It'll be easy. So let's solve for I2. Here's my I2 equation. So I'm going to take I1 and put it in here. And don't forget the negative, okay? You need that negative in there. It goes along how you set your math up. So you do need it. So here we go. I'm going to solve for I2. Okay. Now remember I2, I had that set up at one point, and now I forget it, but it was I2 is equal to, I'm doing this math in my head, negative 30 I1 plus 80 divided by 21. Oh, it's right there. Oh my God, I'm so tired. I just need to stop. Like, it's right there. Some of you kids are going, it's right there. You don't have to do it out again. Well, why not? Have the second time is even more fun if the first time was fun. I already solved it. It's there. So don't do it again. It's right here. All right, so take this and plug it in there. All right, so here we go. I2 equals 1.43 times that, negative 0.86. All right, plus 3.81. So we're set up for that, okay. We can actually go ahead and solve for I3 as well. It's, you know, you can just plug that in here and then go ahead and solve for I3. You get I2 and you get I3. We'll do I2 out for you and see what we get. So 1.43, okay, times negative 0.86 equals negative 1.23. So I2 equals negative 1.23 plus 3.81. Okay, plus 3.81 equals 2.58. So I2 equals 2.58 amps. All right. So now we've got I2 right here, and it's a positive value, which means it did go this way. That means a positive value means the current that I originally had arbitrarily set up is the correct direction. The current is going the way that I had originally set it up. This one's a negative, so it was going the opposite way. If the current comes down here, you know, this current could be going this way, or it could be splitting up and going this way. So we got to figure that one out. Let's go ahead and do that. We'll figure it in this video. Oh my God, there I go. Almost done. Hang in there. Okay, 0.28, leave that there, leave that there, leave that there. 0.258, 0.25, you know, I'll write it right here. All right, 2.58 amps. I'm just doing a lot of babbling, so I'm trying to speed this up. Okay, so take that, plug it in here, or we can just take this value here, and this value here we got from the 1, and put them right in here, and do it that way. But you know what, I'll take this and put it in here. I'll do it here. I'll do it this way. You can do it either way. There's so many choices in this way solving these problems. So many choices. So negative 0.73 times negative 0.86. Okay, don't forget to put the negative in there. And then plus 1.1. All right, so negative 0.73 times negative 0.86. So negative 0.73 times negative 0.86 equals positive 0.628. So that is positive 0.628 plus 1.1 is going to be 1.728 or 1.73. 1.73 amps. Positive, which means the direction that I originally had selected going to the left is the correct direction. So the current going through here is in this direction, 1.73, connects up with this one here, which was 0.86, and together they form 2.58. That should make sense that we have this plus that value, 0.86 plus 1.73 equals 2.58. Yes, so these currents are going like this, connecting, going around, splitting, connecting, going around. All of that work, people. I'm done, I'm tired, I'm out of here. Okay, I'm out of here. Well, I gotta go clean the truck off, and it's gonna take me a while. So I hope you kids appreciated this. I know deep down inside, at least some of you did. Okay, that's how you solve a complex problem. You can set these up in any way, shape, or form that you want to, and you will come out with the same answers. Trust me. You don't believe me? Do it. Set up different loops, set up different current directions, and give them different number values. Solve your equations. You'll get the same answers. All right? Try it.